Hello viewers, welcome back to class. I'm super excited to welcome you back to Master Builders Online Academy. Don't forget to subscribe to this YouTube channel if you have not done so, and ensure that you turn on the post notification bell for more exciting videos. So guys, listen carefully. For your own advantage, do not skip any part of this video, and ensure that anytime you are set to learn new concepts from this platform, do not welcome any form of distraction. And finally, if there be any part in this lesson you do not understand, guys, don't hesitate to replay the video over and over again until you understand it. And if at the end of watching the video over and over again, you still have not understand it, guys, just slide onto the comment section and ask your questions. We will answer your questions either individually or groups. Now guys, let's get to the business of the day. On the board we have integration of type, and we have type 2 on the board. We have integral of f of x and the numerator prime over the square root of f of x, and we have that the answer to this is equal to 2 root f of x plus c. And now let me quickly explain this before we start solving problems using this formula. Here we have a function of x at the numerator, and at the denominator we equally have a function of x. But the function of x at the denominator is enclosed inside a square root. A square root covers all the functions at the denominator entirely. So when you differentiate that function inside the square root and it gives you exactly the function you have at the numerator, then the answer to that becomes 2 the square root of the denominator and plus the arbitrary constant, which is c. If this is understood, guys, let's see how we can solve the problems before us. Now on the board we have problem. We are asked to find the following integral. We have question 1 to question number 4. Now let's take the very first question. Question 1, we are given that y is equal to integral of x plus 2 all dx all over the square root. You must watch out for the square root. Square root of x squared plus 4x plus 11 all dx. Now the first thing you do is to identify the function you have at the numerator and the one at the denominator. At the numerator I have the function of x, equally at the denominator I have the function of x. So first is to try add this with substitution method. And how do we do that? All we simply need to do is to differentiate the denominator, only the function, without the square root. Now the function is x squared plus 4x plus 11. Now when we differentiate x squared, we have 2x. When we differentiate 4x, we have 4. And when we differentiate 11, we have 0. So now at the numerator we have a linear function. Now the derivative of the denominator is equally a linear function. But yet the coefficient of the function at the numerator here is different from the coefficient of that of the derivative of the denominator. So what do? I need to see if I can factorize one of these functions. Now if we factorize the derivative of the denominator, this would have given us 2 open bracket x plus 2. Now we have successfully deduced the numerator from the derivative of the denominator. That means this function is true that when you differentiate the denominator, you obtain the function at the numerator. If this is valid, all I just need to do is to pull down y is equal to. Now the coefficient of the numerator is 1. So 1 multiplied by these 2, we are going to have 2 because this 2 is always constant. All over the coefficient of the derivative of the denominator is 2 over 2, then square root of the denominator x squared plus 4x plus 11 plus c. Then this guy takes care of this guy. Y would have given us root x squared plus 4x plus 11 all plus c. This is the answer to this very question. Very simple. So simple. Now, let's look at the next case. Question number 2, we have that y is equal to integral of x plus 1 dx all over the square root of x squared plus 2x minus 9 at the denominator. Now at the numerator, I have a function of x. Equally at the denominator, I have a function of x. All I need to do is to differentiate the function of x at the denominator. And also we need to recognize that at the denominator, the function at the denominator is enclosed with a square root. That is to say, we already have two roots in function. Now, listen. If we differentiate this, the first thing we do is to put down the what? The denominator, which is 2x minus 9. When we differentiate x squared, we have 2x. When we differentiate 2x, we have 2. And when we differentiate 9 with respect to x, that's 0. Then this is what we have. Now, when we compare the derivative of the denominator to the numerator of the given function, we find that the numerator here is a linear function and the denominator is equally a linear function. That means there is possibility of what deducing the numerator here from the derivative of the denominator. Now, if this is understood, let's quickly check if we can factorize any of these functions, and it is possible for us to factorize the derivative of the denominator. Therefore, we put down 2x divided by 2, we have x, 2 divided by 2, we have 1. Now we already have the numerator, the function at the numerator here when we differentiate the derivative and factorize. In this case, if this is understood, all I need to do now is that I will need to put down 2. Understand that the numerator always have a constant coefficient of 2, which we have here. So put down 2. Then the next is to put down the coefficient of the factor you have at the denominator. And the coefficient there is 2. That will also be the denominator because it occupies the denominator. This is the derivative of the denominator, so the coefficient will be at the denominator. Then the square root of the denominator plus 2x minus 9 plus c. Then finally 2 takes care of 2. Y would have given us the square root of x squared plus 2x minus 9 plus c. This is the answer to this very question. We have y is equal to sine, y is equal to cos x all over the square root of sine x. Now the numerator is a function of x, the denominator is equally a function of x, and the denominator is enclosed with a square root. And what must we do to this? All we simply need to do here, guys, is to differentiate the denominator. Now the denominator is sine x. If I differentiate the denominator, which is sine x, I have cos x. And this and the numerator here, they are exactly the same. So therefore, all I need to do here, my answer becomes the numerator has a constant coefficient of 2, which we have here. So put down 2. Then the denominator now, the derivative of the denominator has a coefficient of 1. So 2 divided by 1 is 2. Then the square root of the denominator plus c. This is the answer to this question. So guys, if at this point you are yet to subscribe to this YouTube channel, do consider subscribing to this channel and ensure you turn on the post notification bell for more exciting videos. Like this video, share this video, and make your necessary comments. Now let's look at question number 4. Question number 4, we have y is equal to integral of x squared plus 5x plus 1 all dx all over the square root of 2x cubed plus 15x squared plus 6x plus 23. This is what we have. Now, when we observe this question, we find out that the numerator is a function of x. Equally, the denominator is a function of x. Now that the numerator is a function of x and the denominator is equally a function of x, what do we do, guys? All we simply need to do here is to first differentiate the denominator. And when we differentiate the denominator, let's see if we can deduce the numerator from there. Now, if we differentiate 2x cubed, this would have given us 6x squared. 3 multiplied by 2 is 6. Reduce the power by 1. Then plus, if we differentiate 15x squared, 2 multiplied by 15 would have given us 30. Reduce the power by 1, we have 30x. When we differentiate 6x, we have 6. And when we differentiate 23 with respect to x, we have 0. This is what we have. Now, when we compare this, the derivative of the denominator to the numerator of the given function, we find out that both are quadratic functions. There is possibility of having the numerator from the derivative of the denominator if we try to factorize. Now, all I need to do is to check what is common between these terms that are here. What is common here is 6. The highest common factor is 6. First, 2 is common. Second, 3 is common. Then third, the value which is the first coefficient of x squared is common. 6 is common. Therefore, we will divide both sides by the highest common factor. Now, when we put down 6x squared divided by 6, we are left with x squared. 30x divided by 6, we have 5x. And 6 divided by 6, we have 1. So now, by factorizing the derivative of the denominator, we obtain the numerator of the given function. Therefore, all we need to do, since the derivative of the denominator gives us what we have at the numerator, then type 2 is valid. And what do we do here? All we simply need to do here is to put down y is equal to, now remember that the numerator by default has a coefficient of 2, which is this 2. Then put down 2. For the denominator, the coefficient that we have is 6. That's what we have. Then the square root of the denominator, 2x cubed plus 15x squared plus 6x plus 23, then plus c. Then 2 is a factor of 6. Therefore, 2 into itself is 1. 2 into 6 is 3. Then we have the square root of 23x cubed plus 15x squared plus 6x plus 23. Then plus constant. This is the answer to this very type. As simple as this. So guys, when you understand principles, you become a principal. And when you understand boundary conditions, you will not overstep your boundaries. Therefore, seek to know principles and seek to understand boundary conditions. Definitely, guys, if you have not subscribed to this YouTube channel, please do consider subscribing to this YouTube channel and ensure you turn on the post notification bell so that anytime we upload mind-blowing content, you will be notified. And also don't forget to share this video, like this video, and make your necessary comments. We love you guys. You can check the description below where you will find the link to the next lesson. See you guys in